Let's take a look at a few examples of how we can use those properties with definite integrals. So this first one, so if we have the integral from 0 to 3 of f of x dx, if we know that equals 4, and the integral from 3 to 6 of f of x dx equals -1, then we're going to find some things. So again, remember, when we see this, we're thinking the area, or the net area of this function from 0 to 3 is 4. And then the net area of our function from 3 to 6 is going to be -1. So if we like to find the net area of our function between 0 to 6, how can we use these properties? Well, what we're given the integral from 0 to 3, 3 to 6, so the property said that I could add these two together. We know that this is going to be the same as the integral from 0 to 3, f of x dx, plus the integral from 3 to 6, f of x dx. And this integral we see is equal to 4. This one is equal to -1. So this is equal to 3. So that is what that integral is equal to. Here, if I want to find the integral from 6 to 3 of 5 times f of x, well, there's a few things that we can do with our properties. One is that if I want to flip these, because I don't know 6 to 3, but I do know 3 to 6. So I'm going to flip this. So to flip it, though, I have to introduce a negative. So I have the -3 to 6 of 5 f of x dx. Now, the other property allows us to do something with this 5. Remember, we can pull that out because the whole thing is being multiplied by 5. So I can pull out the 5, and I have 3 to 6 of f of x dx. And I know what this is. We said that's -1. So I have -5 times -1, and that is equal to 5. So again, just using the properties, nothing too, hopefully, crazy, just kind of following the correct rules. Here, another example, if our integral from -1 to 1 of f of x dx is 0, and the integral from 0 to 1 of f of x dx is equal to 5, what is it from -1 to 0? So this, again, if you think about net areas, we should be able to kind of reconcile what's taking place here. But using the rules, we know that the integral from -1 to 1 of f of x dx is equal to the integral from -1 to 0 of f of x dx plus the integral from 0 to 1 of f of x dx. So we know that we're allowed to separate this into some middle separator. We know that this is equal to 0. Integral from -1 to 0, we don't know. So the integral from -1 to 0 of f of x dx. Integral from 0 to 1, we know that equals 5. So just solving for this, I see that's going to be equal to -5. So -5 is equal to the integral from -1 to 0 f of x dx. And again, I mentioned that we want to think about this as net areas. The idea is that if I have the integral from -1 to 1, I have this chunk. Half of it has an area of +5. The whole area, the whole net area is 0. Well, then obviously, if the other one has the same width, then it has to have the same, the opposite sign of this. So it has to have the same number, just the opposite sign. And so indeed, we see that as -5.